Yes, hi everyone. I think I'm audible to all of you. Let me know in the chat. Guys, am I audible? Hi Amarnath. Hi Rakesh. Okay, so let's wait one more minute so that everyone can join and we can start with our webinar. Yeah, hi Imtiaz. Hi Frank Miller. Hi all of you. Thanks for the confirmation and very good evening to all of you. So I think guys you are doing well. Everything is good from your end. Okay, so welcome to our webinar on this advancing visual intelligence. Yes, hi Franklin. Hi. Thanks for the confirmation. Okay, so I think guys we can start with our webinar. So I think you saw guys the topic name of the webinar called advancing visual intelligence. So here we'll try to see what is this visual intelligence is and the latest, let's say, trends inside the computer vision domain, because so many people they are working in the field of generative AI NLP. So people are working on the text data so far, right? But computer vision is also trending a lot nowadays. Okay, there are so many things are coming inside computer vision as well. Even personally, if you ask me, I love computer vision a lot because I love to work with images and videos. Okay, so how many of you are like interested in computer vision here? Let me know guys. Like me, I see. I like generative AI, but personally, if you ask me, like in which field actually you love to work more, so I'll tell computer vision. So nowadays, generative AI came in the market. That's why people are moving to that. But previously, computer vision actually was the very trending, let's say, domain. Okay, in the field of artificial intelligence. So I'm just learning from you. Franklin is telling, I'm just learning from you. Okay, great. So if you, yeah, if you see my tutorial, if you see my YouTube channel or let's say any other platform, so I have lots of content related computer vision. Okay, whether it's classification, object detection, segmentation, okay, tracking, and then GANs. Okay, so everything I have already created lots of tutorial. Even I have a like very good news for you. So just be with me. I'll let you know about the good news. So those who are interested in the field of computer vision, so for them actually this is the good news. Okay, yeah. Okay, fine. So I'm doing the research in CV. Imtiaz is telling I'm doing research in CV. That's great. Okay, let me know in which field you are doing the research, whether you are researching in the classification of the detection, segmentation, or okay, image manipulation. You are doing great. Yeah. Even if you open like nowadays research gate, so there are so many research actually people are also doing on top of this computer vision. Like currently diffusion model also came in the market, so you can also play with the videos and images. Okay, that means in generative AI also people are using hybrid architecture, so they have integrated computer vision as well as the NLP architecture, and they created hybrid architecture. Okay, and we call it as a multi-model, so both can work. You can give also text, you can also give videos, okay, you can also give images, anything can be done. But the core computer vision you have to understand, if you want to understand these are the advanced architecture, okay, how things are working. So always I suggest my students try to good with the fundamentals, then you can switch to any, okay, any kinds of, let's say, advanced topic. Okay, but if you're not clear with the foundation, so things would be more difficult. Okay, Frank Miller is telling I'm curious about computer vision. That's great. Okay, if you're curious, just be with me. I'll let you know about the good news. Okay, great. So, guys, I think we can start. But before starting, guys, let me introduce myself. I think there are so many people they already know me. But if you don't know me, so my name is Boktiar Hamid Bappi, and I'm having more than 5 years of working experience in the field of Python, machine learning, deep learning, MLOps, generative AI, and robotic system. Okay, so I used to work in the robotics in my career. When I started my career, I used to work in the robotics field because my education background, I'm from electronics, actually engineering background. Then I switched my career into data science. Okay, yeah. And these are my social media. If you want, you can also connect me. Okay, anytime you can connect me, so you can see my social media link. So this is my LinkedIn, this is my personal YouTube channel, this is my GitHub. Okay, apart from that, if you want to mail me, you can mail to bappi@euron.one. Okay, anytime you can mail me there with any kinds of query. Okay, so first of all, let me start with the visual intelligence. Okay, so first of all, I will give you the introduction. Then we'll try to see this visual intelligence with our actual intelligence system, like our visual cortex. Okay, like in human brain, also I think you saw we have actually visual cortex. Okay, with respect to that, we are able to see something. Okay, we are able to recognize something. That means I'll try to compare with the actual human brain. Okay, how things works, actually how researcher got the idea. Okay, that's how visual intelligence can work. So how they mimic that particular, let's say, strategies, everything I'll try to show you. Then we'll see one practical demo. Then I think this part would be more clear to you. So how did you get an internship about CS degree? So I didn't get into the internship, but later on actually I switched my education also to the computer science. Okay, engineering. Priyanshu, can lead code questions will be covered in the DSA Python course? Yes, I think it should be also covered. You can check it out, the course curriculum. Maybe and there are some numbers also. Maybe you can also contact them. Okay, they will let you know. I think this is the course of Prince Kathiar, so maybe you can connect with him and you can ask about that. Okay, whether this would be covered or not. So fine, guys. So I think we can start our visual intelligence discussion. So first of all, let's try to see what this visual intelligence is. Okay. So see, this visual intelligence, we also call it as computer vision. Okay. So many people, I think they are already familiar with computer vision in artificial intelligence. Computer vision. Fine. So guys, how many of you are familiar with computer vision here? So I think all of you. If you don't, no need to worry. I'll let you know. Okay, how you can get familiar with. Fine. So what is this computer vision exactly? So if you ask me the definition, so I'll tell it enables, okay, enables machine or computer, okay, to have a vision system, okay, close to human, close to human. So this is called actually computer vision. That means it enables machine or computer to have the vision system close to human. Now, if I show you one image, actually, maybe you will be able to understand what I'm trying to say exactly. So let's say this is one image I'm having. Just try to see the image. See, this is the completely computer vision demo. Okay, you can see in this particular image. Even you can also compare. Just a minute, I think I can. Ah, so see here you can also compare with the actual, let's say, human intelligence. Okay, how things are working. So let's say in human vision, what happens? Let's say if there is any object present. Okay, let's say there is a cat and dogs. Okay, in front of you. So first of all, what you usually do, you usually see that particular object with your eyes, and these eyes will send that signal to the brains. Okay, and brain will try to process that image, and it will try to make the decision whether it's a cat, whether it's a dogs, whether it's a horse. Okay, that's how it will try to classify or detect, okay, or anything. Now in computer vision, the same thing we just try to mimic here. Let's say this is the same input, let's say the dog, then cats. Okay, these are the things. Now we use something called sensing device. Now what is the sensing device? Sensing device means this is called actually vision input. That means the camera. Okay, whatever camera we usually use nowadays, this is called sensing device. So it will try to capture that image, okay, capture that object, and it will send it to the interpreting device. And what is the interpreting device? That means this is your computer. Okay, and now computer we can compare with the brain because it has the computational actually functionality. That means it can compute that input and it can make the decision. Okay, with respect to that, it will tell you whether it's a cat, it's a dog, okay, or any other object you have here. But computer, simply computer won't be working. For this you have to use some machine learning approach, okay, to make the decision, to interpret the decision. Okay, and this where actually computer vision comes into picture. That means inside computer vision we use some neural networks. Okay, we use some machine learning algorithm to make the decision. Okay, so that means we'll be creating the model and we'll pass the data into the model, and my model will try to decide whether this is a cat image, whether it's a dog image, or it's a, let's say, horse image, okay, or any other image actually you have in the input, right? So this is what actually entire system works. Okay, this is the actual human vision and this is the computer vision. Now you can, I think, understand this particular definition. That means here we just try to mimic the human vision system. Okay, close to human vision system, not the exactly one, but at least close to. Okay, we try to mimic here. Okay, I hope it makes sense, guys. Let me know. Bring something on how to work with the voices. Definitely, Rohit will try to okay, bring that content also. Okay, yeah. Okay, now computer vision works in three basic steps we just need to follow whenever we're working in the field of computer vision. So these are the uh, three. Just a minute, what happens? Just a minute, guys. Mm, so I have another image. I'll try to paste it here, but it is collapsed. Just a minute, guys. Now it is fine. Now you can see these three step we have to follow. Okay, so first of all we have to acquire, okay, we have to acquire the images, okay, with the help of sensing device. So we can use camera, okay, to actually collect these are the image. Even nowadays there are so many website, they also provides the data you can use. Then we'll try to process that image. Okay, processing means we'll try to do some processing, some augmentation technique. Okay, so these are the thing we'll try to perform. Then we'll do the understanding the image. That means here we'll try to create the model. Okay, vision model will try to create, and my model will able to recognize, okay, what kinds of input it is. So these three steps we have to follow always. Okay, these are the steps we have to follow. Hmm. Fine. Okay. Now see, inside computer vision, I think you know about the deep learning, right? So computer vision falls inside deep learning. So deep learning. So how many of you are familiar with deep learning, guys, here? So I think in deep learning you have learned about ANN. Okay, that means artificial neural networks. Then we have another kinds of neural network called CNN. So this is called convolutional neural network. And then we have another network called RNN. Okay, that is called recurrent neural network. So this is the foundation of deep learning. Foundation of deep learning. So here you will try to understand about the neural networks. Okay, how neural networks works. Okay, how we can create the neural networks. What is the activation function? What is the sigmoid function? Right. So everything you will be able to understand. Okay, in this ANN part. Then once ANN clear, then you will be starting with the CNN, that means convolutional neural network, and this is your computer vision. Okay, computer vision starts here. Okay, now inside computer vision, you have different kinds of tasks. Let's say you have something called image classification. Okay, image classification. So here you will try to classify the image. Then you have image, or I can just write. We have object detection. Okay, so here we'll try to detect the object detection. Okay, then we have object segmentation. Segmentation. Okay, so here we'll try to do the segmentation task. Then we have object tracking. Okay, object tracking is there. So here we'll track the object. Then we have GANs. That means generative adversarial networks. Okay, so with the help of GANs we can generate a new content, generate a new image. Okay, it's possible. Then we have another kinds of neural network called RNN. So we use RNN for the NLP task. Okay, NLP or GenAI. Okay, whatever you are using nowadays, generative AI. Okay, we'll be using RNN. This is called recurrent neural network. So CNN will work, okay, pretty good with the images and videos data. RNN will mostly work good with the textual data, or let's say time series data. NN will mostly work, okay, with respect to the tabular complex kinds of data. Okay, so these three kinds of neural network we have inside deep learning. Okay, so that's why foundation is always required. Now let's say you don't know about the NN, artificial neural network, so understanding CNN would be a little bit hard for you. Not little bit, I can say it would be very much hard for you. Okay, because all the artificial neural network concept will be using in the CNN. Because if you see the CNN architecture at the end, okay, at the end we have the ANN architecture integrated, and which works for the voice, this RNN only. Okay, because voice is at the end, it's a text. Okay, it's a sequence of, let's say, what sequence of speech na at the end. Because what is voice? If you convert voice to, I mean, frequency, at the end it's a frequency, right? And if you convert to the frequency, so it will be giving you the text, like we can transcribe that, right? So whenever I'm talking about the voice, the first thing we have to do, we have to transcribe that voice to the text representation, then we'll be working with the RNN. Okay, frankly, I hope you got it. Okay. Hmm. So here in the visual intelligence, you will be mostly working in the field of CNN, that means convolutional neural network. Okay, we'll be working on that particular part. Okay, now for each and every, okay, for each and every, let's say, task, we have different model inside computer vision. Let's say for image classification, we have ResNet, we have VG16, okay, we have Inception Net, we have Dense Net, we have Mobile Net. Okay, these are the architecture we are having. And also we use something called pre-train architecture. We call it as a transfer learning. Why we call it transfer learning? Because these are the model has been trained with a huge amount of benchmark data. Okay, so have you heard of these ImageNet data, guys? Anyone here? ImageNet data, image net data. Okay, ImageNet data is a benchmark data inside computer vision. So it is having 1000, okay, 1000 category. Okay, 1000 category. And I don't know the exact amount of the let's say image they are using in in this particular data set, but I think it is more than millions. Okay, so they use the data to train the model. Okay, now I can show you all the model here. Let's say if I go to the website and if I search for Keras application na, Keras application. So here you will see the list of the model you have here. These are the pre-trained models. See, you have exception, VGG16, 19, ResNet 50, ResNet 50V2, ResNet 101, okay, DenseNet, EfficientNet, CompNet, and so on. Okay, even you can see the parameter size also. So this exception net is having 22.9 million parameter. Okay, so that must actually parameter you have in this model. This is the size of the model. This is the top accuracy of the model. Okay, then this is the depth of the model, this is the time performance on the CPU, this is the time performance of the GPU. Okay, that's how you have all the, let's say, model. Okay, in the Keras and TensorFlow, or if you're using PyTorch also, from there also you can get the model. Only what you just need to do, only you just need to call the model. Okay, you have to tweak some last parameter, then you can train on top of your custom data. Even you can also use this particular model as it is. Okay, no need to train from scratch. Is there any real application of ANN in the recent trends? I can say no. ANN we don't use for the real-time application building, because most of the tabular data can be solved with the help of machine learning algorithm. Okay, not with the ANN. Because let's say if you can kill a bird with a like a stone, why you will be using rocket lancer for that, right? So ANN is the rocket lancer, ML is the stone. Okay, so I can kill a bird with a stone, but okay, I don't need to use the rocket lancer for that. Okay, but ANN is a like very powerful actually architecture, because it can understand the complex pattern from the data. Sometimes let's say if your data is like very complex, that time you can use ANN. Okay, but I've seen most of the problem statement can be solved with the help of machine learning model if you're using tabular data in case. Okay, but whenever you have unstructured data, unstructured complex data like image, videos, text, that time you have to move on to the CNN or RNN networks. Okay. Hmm. I know MNIST. MNIST is a handwritten data set. It is a different kinds of data set. Okay, it's not actually image then data set. MNIST is like very, basic kinds of data set. It is called actually grayscale image. Okay, not the color image. Hmm. Then we in object detection also we have different kinds of architecture. Like we have faster RCNN. Okay, so here I can write. I think you can understand. So let's say for image classification. Okay, image classification, we have different kinds of model. I showed you, like we have VGZ 16, we have 19, we have exception. Okay, exception, we have dense net. Okay, and so on, resnet. Then in object detection also, object detection, we have different kinds of architecture. Like we have faster RCNN, faster RCNN. Okay, we have SSD, that means single shot detector. We have YOLO. Okay, YOLO, you only look once, and YOLO is having different version. Like it is having YOLO V5, V6, V7, V8, V9. Even I think V10 has also released, and V11 is also there. Okay, so I personally like YOLO a lot. Why? Because at the last of this webinar, I will show you one demo. Okay, of the YOLO. Then for the object segmentation also, we have different kinds of architecture. Object segmentation, we have different kinds of architecture. Like we have mask RCNN, mask RCNN. Okay, and we have detectron 2 also framework we can use for the segmentation task. Okay, then for the object tracking also, we have different kinds of architecture. So we use something called uh, for object tracking. There is actually architecture. This is like very popular, called deep sort. Okay, deep sort. Okay, with the help of deep sort, and we have something called byte track. Byte track also we can use for the tracking task. Okay, so these are the different architecture we have. But first of all, let's try to understand. Okay, first of all, let's try to understand how this vision system works exactly. Like whenever, let's say, we are giving an image. Okay, whenever we are giving an image, how our brain is processing that, and how researcher got the idea. Okay, that's how they have to create the architecture. Okay, first of all, let's try to understand the CNN, how CNN works exactly. Okay, convolutional neural network, how it works and how it understand the image. Okay, for this I will do one like very basics comparison. So I already created one PPT. I think you can see the PPT, guys. Okay, so let's try to differentiate CNN versus human visual cortex. So here, let me take my pen. I'll take a different color. Hmm. So guys, here you can see I have something called visual cortex. Okay, you can see this is the visual cortex. That means this is the complete the human brain, and here you have something called visual cortex area. So this is called actually visual cortex area, this particular part. So here is the part you can see. This part is called visual cortex. So those who are from biological background, I think you already know about the brain structure and all, right? Yes or no? And it's a visual cortex also, you have different parts. Like you have V1, V2, V3, V4, V8, V7. So it is having different parts with different colors, you can see. Okay, now what happens, let's say, how we usually see any object. Let's say there is an object. Okay, there is an object. First of all, what happens, light will actually fall on top of the retina. Right will reflect on top of the retina. So this is called actually retina of your eyes. Okay, retina of your eyes. Now, now what will happen, you can see from the retina there is a uh, see, there is a pipe. This is not a pipe. Okay, this is called actually optical nerve. So this, what is called, this is called optical nerve. Okay, optical nerve. You can also call it as a axons. Okay, axons. So this is kinds of actually, let's say, I mean, what I can say, this is actually way of uh, your electric impulse can go, okay, from this particular, let's say, optical nerve. That means it will generate something called electric impulses. Okay, these electric impulses will go from this particular path, okay, from this particular optical nerve, or we can call it as a axons. Then it will come to this particular part, and this is called actually thalamus. Okay, I can write thalamus. Okay, thalamus. You can also call it as a LGN. Okay, what is LGN? You can search over the Google, you will see the full meaning, but you can call it a thalamus. So inside thalamus, what happens? Whatever, okay, signal you are getting, whatever electric impulses, okay, it is getting, it will try to process that here. Okay, then after processing, what will happen? It will again send, okay, from this particular axons. Okay, it will send from this particular axons and will reach to the visual cortex area. Okay, then first time it will go to the V1 region. Okay, this particular region your signal will go, and this is called catalog input. Okay, catalog input, and this is also called striate cortex. Okay, this particular area. Okay, we call it as a primary V cortex, visual cortex. This part we call it as a primary visual cortex. That means the first signal it will go to the V1 catalog inputs. We call it as a primary visual cortex. Okay, this area. I hope you got it, guys. Right? Okay. And from here, your brain will try to understand what kinds of, let's say, signal it is and what kinds of object actually you have in front of your eyes. Okay, based on that, it will make the decision. Okay, so that's how your entire human, okay, visual cortex will work. Okay, so this is the like just one part of the brain. Now let's try to see the actual CT scan brain. Okay, how it works there. So I'll clear the board and let me change this. Now I think you can see there is another image I kept. So this is what your actual brain CT scan image you can see. Okay, this is the actual brain CT scan image. And the example I showed you, this is the one side. Okay, this is the one side of the brain. Now let's try to see how it will work in the both side. Because if you divide your brain, you have two sides. This is the first side, this is the second side, right? So here what happens, let's say here is your eyes. Okay, here is your eyes. So first of all, this light will, okay, reflect on your eyes, and the signal, that means electric impulses, will go, okay, from the axons, and it will reach where? Okay, it will reach to the um, here it will reach to the thalamus. Okay, this is called thalamus. And how it will reach? From this particular axons area. Okay, this is called thalamus. Okay, and from the thalamus it will process that particular electric impulses, and again it will, okay, release the signal from these axons. Okay, and it will reach to the visual cortex area, and this is what your visual cortex area, you can see, this is what visual cortex area. Okay, now you can see this is the both part of your brain. This is just only one part and this is the both part. Okay, I hope you are getting, guys. Okay, that's how things works. Okay, whenever I'm talking about human intelligence, that's how things works. Okay, maybe it's not visible, let me change my presentation. Now I think you can see, right? So this is the actual brain architecture. So here you have the eyes. So first of all, lights will reflect on the eyes, and it will generate electric impulses. These impulses will go, okay, through these axons. It will reach to the thalamus. Okay, thalamus will process the signal. Again, it will release, okay, through these particular axons, and it will go to the visual cortex area. Okay, and from there your brain will make the decision whether what kinds of image it is, okay, in front of you. Okay, that's how things work. Now we'll try to understand, okay, how it is processing, let's say, how what kinds of object we have in front of me, whether it's a cat, whether it's a dog. Okay, how it is identifying that particular object. We'll try to understand how your brain is getting the signal. Okay, how it is extracting the features. Okay, we'll try to understand this part. And the same concept, okay, whatever CNN model you use, okay, it uses nowadays. Okay, so for this we'll try to see one amazing experiment. Okay, two researchers did. So let me show you the experiment name. So this is the experiment called cat experiment. Okay, there were two researchers called Hubel and Wiesel. Okay, so there is a video link I can show you. So this is the YouTube video link, guys. So here you can see this is the experiment actually they did. So what they did actually, they took one cats. Okay, let me show you. So they took one cats. Okay, see, this is the cats, and they gave the anesthesia actually to the cats, so that cat can't actually, let's say, move, but cat can see, but it can't move actually. Got it? So you can see, and they use electrode. Okay, they pushed one electrode in the brain of the cats. Okay, and they did the experiment. See, this is the video. Even I will share the video with you. You can see later on. So these two researchers actually did the experiment, and what they did, they kept actually one display in front of the cat, and they showed some of the shapes. Okay, and they were recording the signal from the cats. Okay, this is the experiment they did. See, it was like very old video. That's why resolution is not good. Yeah, they see they did with the cats, even the monkey as well. So this was the first research actually happened whenever they were actually working on the computer vision part. Okay, like they were trying to understand, okay, how our brain process the signal, okay, how we understand any kinds of shapes. Okay, that's why they did the signal. I will be discussing more about it, okay, how they're doing. Okay, we'll try to see, but this is the video you can see right now. See, now see, they're showing different shapes in the display. Okay, after putting the, okay, after putting the electrode in the brain of the cat, and they're recording the signal of the brain of the cat. Okay, see, this is the entire video. So let me share the video with you also, so that later on you can see that. So I'm sharing in the chat. So this is the video, guys, you can check. So now let's try to understand, okay, what they did actually in the experiment. So what I will do, I will again share my screen. So guys, I think you can see one image. Okay, right, you can see one image. So see, this is the experiment setup they did. Okay, you can see this is the experiment setup they did. That means this is the cat, and what they did, they put one electrode. This is called actually electrode. Okay, electrode. I think you know what is electrode, guys. Those who are from electronics background, I think you know, because inside our brain actually we have actually electrons. Okay, electric impulses, and to get that signal we can use electrode. Okay, without electrode actually you can't do that, so that's why we have to use the electrode. Okay, you can see this is the electrode. That means, let's say this is your brain tissue. Okay, I think you can see that, otherwise I can show you. See, this is the brain tissue. This is the actually oscilloscope zoom actually brain tissue. You can see that's how your brain tissue looks like. Okay, that means the cat brain tissue looks like. So what they did, they selected one part of the tissue. Let's say this is the part they selected, and here they put the electrode. Okay, they put the electrode, and they started recording the brain signal. Okay, this is the setup, and this is the display. Okay, this is the display they kept in front of the cat, and in the display they were showing some of the shapes. Now see, this is one kinds of shapes they are showing. Okay, so this is not a horizontal, this is not a vertical, this is a little bit rotated horizontal shape, I can say. Okay, now you can see the experiment. Let's say at the very first time they are showing these kinds of shapes, these kinds of shapes. Now there is no signal from the brain of the cat. You can see there is no signal. Then they what they did, they rotated a little bit. Okay, they rotated a little bit, and you can see there is no signal again. Then again they rotated a little bit, that shape, and now they got some signal. You can see they got some signal from the cat actually brain. Now they were understanding, okay, now we started receiving a signal. Now what I can do, I can rotate a little bit. Now again they rotated a little bit, this particular shape. Now are getting, they're getting more signal here. Now completely they have did the vertical actually, let's say, rotation. Now you can see cat is generating more signal here. It is getting more signal here. That means they're understanding this particular part of the tissue. That means this particular part of the brain is able to detect horizontal shapes from the image. Okay, that means inside our brain also we have different parts. Okay, in the visual cortex we have different parts. So every part is having different power, different recognition power. One of the part can recognize vertical line, one of the part recognize can horizontal line. Okay, line. One of the, let's say, part can recognize circle line, That's how our brain will try to see actually different shapes, okay, and by combining the shapes, okay, it can understand the complete image you are having, okay, in front of the display, or let's say whatever you are watching that. Okay, now again they did little bit rotation, again see this signal is getting down, again actually you can see they're doing the horizontal operation and there is no signal. That means from the experiment they got to know this part of the brain is able to detect the horizontal shapes, okay, from any kinds of image. Now whenever I'm drawing any kinds of image, let's say I'm drawing one cat image, or let's say I'm drawing one dog, let's say this is the dog. I don't know how to draw dog, but what I can do, let's say I can copy a dog image from the Google. Just a minute. Dog image. Let's say this image I can use. See, this is the image, guys. You can see. Uh, I hope it is visible. See, every image you can see it is having different shapes. Okay, how you can see? Let's say this is called horizontal shapes. Okay, this is called vertical shapes. Okay, again vertical shapes, again horizontal shapes. Okay, so every part of the image is having some shapes. Okay, because our brain first of all will try to process the shapes. Okay, what is the shapes and all about, then it will combine all the shapes together, then it will consist the image. Okay, so that's how things works. Yes or no, guys? Let's say if you are an artist, okay, if you are an artist, so how it will draw an image? First of all, tell me, if I give you any kinds of image, how you will draw? First of all, you will draw the shape. Yes or no? Let's say this is the dog. First of all, you will draw the shape of the dog like that. Yes or no? Okay, let's say this is leg, this is tail. Okay, I'm not good at drawing, but at least try to see. Okay, so first of all we'll try to draw the shapes, then we'll make the color. Okay, we'll give this uh, i mean uh, uh, this particular, let's say, color and all, everything we'll try to put, right? Just try to understand, okay, with the philosophy. Let's say if you're an artist, if I give you one image, first of all how it will understand? By seeing the shapes, because my brain can understand the shapes. What is the shapes of the dog, what is the shapes of the cat, what is the shapes of the human, what is the shapes of the car. Okay, then it will try to identify, okay, what is the color, what is the, let's say, brand of the car, then it will try to understand. We'll draw outline first. Yes, super kids sit, you are right. We first of all try to draw the outline first. Okay, the same thing is happening at the end, because you can see this is called actually shapes, different shapes, and we call these shapes as the edges. Okay, edges. In computer vision we call it as the edges. So first of all we have to detect the edges of any kinds of objects. Okay, that's why in the experiment you can see, okay, if I show you the experiment, if I show you the experiment, you can see they're showing different shapes, whether it is a vertical shapes, it's a horizontal shapes. Okay, they're showing at the first of all. Okay, at the very first time they're showing, and they're recording the signal, and they're trying to understand, okay, which part will able to detect which kinds of signal. Okay, now here I think you can understand, this part actually is able to detect vertical shapes. Now let's say they again change the electrode in this particular let's say tissue, or let's say this particular part of the brain, and this part is able to detect, let's say, vertical shapes. Let's say they use this particular part is able to detect, let's say, circular shapes. Okay, so that's how they were trying to understand, okay, which of the part is able to detect what kinds of shape. This was the experiment, guys. Did you get it? Let me know. Any question? Any question about this experiment, guys? I have no. Fine. Okay. Now see, after this experiment, they got some outcome. Okay, they got some outcome. So they got actually two kinds of cell. Okay, one is the simple shell, another is the complex cell. Okay, they got two kinds of cell. One is the simple cell, another is the complex cell. Okay. Now see, this simple cell can Okay, this is called actually also called oriented cell. Okay, and this is called actually feature detector also. Feature detector. Detector. That means it can detect different edges. Okay, what kinds of edges? Let's say horizontal edges, vertical edges, horizontal edges. Okay, these kinds of edges it can detect. Okay, and it can only detect smaller edges. That means these kinds of smaller edges only. Now if there is a circular, let's say, edges, it can't detect because it's a bigger actually, let's say, edges. Okay, it can only detect these kinds of small edges, this simple cell. And there is another cell called complex cell. Okay, and this cell can work on the bigger, okay, bigger receptive field. Receptive field. Bigger receptive field means it can detect complex edge. That means bigger edge. Let's say if there is a circular edge, okay, this particular cell can detect. If there is a square shape, okay, this particular cell can detect. Okay, so that's how we have two kinds of cell, okay, in the brain: simple cell and complex cell. Now here is the actually, uh, I mean, you can see the biological image. This is the machine image exactly. Okay, so this is one actually complex, this was the simple cell. They used actually different machine, and this is the picture of that particular cell. Okay, yeah. So by using the simpler cell and complex cell, it can detect, actually it can understand any kinds of shapes. Okay, whatever image actually you are showing, first of all it will try to extract the smaller shapes, it will combine the smaller shapes, it will try to understand the bigger shapes, then it will try to understand the object. Okay, what kinds of object it is. Fine. Hmm. Now see, this is the this is the actually research experiment they did, and they came up with, okay, they came up with actually this kinds of architecture. You can see this kinds of architecture. That means, let's say this is the input. Let's say this is one kinds of shapes. So at the very first stage, that means at the simple cell, because it will go to the cell first of all in the brain, and simple cell will try to detect the smaller edges. You can see this is the smaller edges, that means some vertical horizontal line, oriented line. Then stage 2, it will use the complex cell to understand the complex pattern. That means bigger actually edges. Now you can see this is the bigger edges. That means you can combine, okay, these are the smaller edges, and you can make the, okay, bigger edges. That means complex edges. Now you can see this is one kinds of shapes. Okay, now there is another stage. That means, see, in the brain also it's not like that we only have two cells, it is having thousands of billions of million cells. Okay, so let's try to consider this is another cells, this is another complex cell. It will again try to understand the bigger cells. Now there is another cells, okay, complex cell. It will try to combine all of the shapes together, and it will try to understand what kinds of input you are giving. Okay, so that's how actually things works. And by this particular concept, okay, they introduce something called CNN, convolutional neural network. Okay, CNN works in the same way. Inside CNN also we have the feature extractor. Okay, we have the feature extractor, that means the copy of cell. Okay, that particular architecture can understand these are the edges, these are the features. Okay, now see, this was the first architecture they proposed called uh, neocognition. Okay, neocognitron. Okay, neocognitron. So Japanese scientists, they introduced this particular architecture. Okay, you can see. So this is the hierarchical multi-layer artificial neural network proposed by Kuni Hinko, what is the name, Fukushima. Okay, in 1979. Okay, so he introduced this particular architecture, and this architecture they used to use for the, I mean, medical, I think, text recognition. I'm not sure, but they introduced this particular architecture at the very first time. Okay, these are the actually different cell you can see. Okay, this is called CNN. Okay, now things actually evolve. There were another researchers, actually his name is actually Jan Likan. Do you know about him, guys? Jan Likan. So currently I think he is working with the Meta. So he was the actually first actually researcher. He introduced one amazing CNN architecture called linet 5, and this is the architecture of linet 5. You can see these are the convolutional layer. So these are the cell, and you can also call it as a feature extractor. Okay, so linet 5 is one of the earliest pre-trained model proposed by Jan Likan and others in the year of 1998. In the research paper, gradient based learning applied to document recognition. That means they introduced this particular architecture to recognize the documents, that means the handwritten digit. Okay, they used architecture for the recognizing handwritten and machine printed characters. Okay, you can see. Okay, for that actually they introduced this particular architecture. And from this architecture, whatever architecture you can see nowadays, like means the VG16, ResNet, okay, then AlexNet, all the architecture came, but this was the core architecture, and this was the actually first, actually let's say, mechanism of the CNN, okay, from the human brain itself. Getting, guys? Let me know. And this is what your visual intelligence, okay, visual intelligence, the copy of the visual cortex of the human brain. For NLP also we use another part of the brain. That part actually can, let's say, recognize any kinds of text, voice, okay, because in the brain we have different segment. For voice, text, we have another part. For image visualization, we have another part. Okay, for decision making we have another part. That's how we have multiple part in the brain. And at the end, this artificial intelligence is the copy of that particular brain, okay, in a mathematical representation. That's it. Sorry, I think now I'm audible, guys. Sorry, I think my mic was mute. Yeah, Suleiman Ahmed is telling hi. Uh, I joined a little bit late. Can you just reiterate the current context so that I can catch you? See, here we are. Now, am I audible, guys? Can you hear me? Hmm. Just let me check. Just a minute. Hmm. Now I think I'm audible. Yeah. So see, here we are just see, doing the discussion on the visual intelligence. So we compared with the human brain visual cortex. Okay, how, let's say, we usually process the image, and how our machine process the image. Okay, how it does the feature extraction. So we see one experiment. Okay, that's how we have done the discussion so far, Suleiman. Okay, maybe you can see the video from beginning. Okay, so now let's see one practical demo. So see here, in just only one, uh, webinar, it's not possible to show you the entire computer vision. So if you're interested learning computer vision, guys, I have amazing announcement for you. So I started a computer vision course recently on our platform Euron. Okay, you can see this is the course, computer vision with real time development. So this course has started from 8 January 2025. I think two classes has happened only, right? Two classes I took. Even it is also available over my YouTube channel also, you can check it out. So if you're interested learning computer vision, so guys, you can enroll for the course, okay, and see the curriculum. That means we'll try to cover each and everything, whether it's image classification, object detection, image segmentation, okay, object tracking. Even we'll also try to implement different projects. Okay, that means this would be the complete computer vision course. And if you see the course price, it's super affordable. Okay, let me show you the course price. It's only $24. Okay, and this is the live class, guys. Okay, but if you ask me, I will suggest you go with the Euron Plus subscription, all of you, because Euron Plus subscription is only 2,909 rupees per year. That means you can access all the courses from the Euron side, whether it's a live course, recording course, okay, anything you can access. But if you're taking individual courses, then you can't do that. For another courses, you have to again buy that. But if you're taking the subscription plan, you don't need to buy that. Okay. So almost close. If you compare the $24 with 2,990 rupees, 90 rupees, okay. If you convert it to a dollar to rupees, you will see that almost close. Okay. Yeah. So maybe your this subscription plan would be better. Okay, if you ask me. So you can join the class, guys. So it is one of the amazing course I have designed. So we'll try to learn everything, okay, about the computer vision. So those who are interested in computer vision, guys, okay, you can join this particular course. Fine. So now let's try to see one practical demo of the visual intelligence. So here we'll try to see one object detection demo. Okay, object detection demo. So first of all, try to understand what is object detection, image segmentation, and image classification is. Okay, so I'll show you another image. So this image actually I have. Uh, Here is the image. Okay, see, this is the image. Okay, so I already took one class, so that's why I written on my board. I copied the image from there. So see, guys, what is the difference between classification, object detection, and segmentation? See, this is the image. In this image, we have only cats. Okay, and here we are trying to classify only. It's a cat image. Okay, or let's say it's a dog image. Then we have another, let's say, task. So this came actually before the object detection. This is called classification and localization. That means it will also give you the location of that object. Okay, in which location this object is present. Okay, but it won't be giving you the name on top of the detection box. Then there is another task proposed. This is the updated version of the classification called object detection. Okay, sorry, classification and localization. This is called object detection. So inside object detection, what happens? So if you have multiple object also, let's say dog, cats, or whatever, it will try to detect that object with the location as well, and it will also give you the category, whether it's a dog, whether it's a cat, whether it's a horse. Okay, this kinds of category it will also give you. This is called object detection. Then you have another application called instance segmentation. So it will try to segment that particular object. Okay, see, in object detection there is some background, okay, are coming, but segmentation there is no background. It will segment that particular object only, not any other background. Okay, so these are the actually difference between classification, object detection, and instance segmentation. So I'll show you one demo of object detection today. Okay, how object detection can be done with one of the amazing model called YOLO 11. Okay, personally I like a lot because it is like very easy to set up and easy use. Okay, and it is like super fast. And if you want to understand what is YOLO, how YOLO came, how to annotate the data, how to prepare the entire, let's say, the complete, actually practical, you can join that course. Okay, because I told you in one webinar it's not possible to show you everything. Is the course having content with legacy models with generative AI image based model? No, it is the core computer vision, Amarnath. Okay, that means here all kinds of computer vision foundation will try to understand. This is not related to the GNAI. So if you understand this course, understanding your GNAI architecture would be easy for you. Okay, whatever, let's say, diffusion GANs architecture you are having, it would be easy for you. Fine. So to show you one object detection demo, I already prepared one notebook. So this is the notebook, guys. So let's see one demo how we can train one object detection model. So I think I can zoom my screen. Now I think visible. So this is a collab notebook, guys, I prepared. So let me connect the notebook. And this is the data I'm going to use. So this is called actually helmet data. Okay. So this data is available in the RoboFlow universe. So RoboFlow universe is one of the platform. Let me show you RoboFlow universe. So it is one of the platform. It is having almost all kinds of computer vision related data. Let's say you are looking for object detection data, you can filter out. See, it is having different data. Okay, so from there I'm using one of the data called helmet detections. It is having helmet images, you can see. Okay, you can see helmet images. It is having different helmets, but it's a bike's helmets. Okay, it's a different helmets it is having. So we'll try to use the data, and you can see number of classes. So you have cycling helmet, you have half face helmet, hard hat helmet, helmet, modular helmet, motorbike helmet. Okay, no helmet. See, these are the category it is having. So we'll try to detect these are the category. Okay, in this example. So how much cloud storage or GPU required for your small model deployment on the cloud? See, for deployment, actually, you don't need that much of like good configuration machine, but for training actually you need. Okay, and most of the model we can train with our Google Colab. If you're using Google Colab Pro subscription, maybe you can train. And see, YOLO training, YOLO is like very I mean, it's like super easy. Okay, I'll tell you. If you're using free Colab also, even you can train also. So I'm going to show you one example, see how things will work. Hmm, fine. So first of all, you have to create one account in the RoboFlow. So to create the account, just go to the RoboFlow universe, and there you can create an account. Okay, then you will be able to access the data. So let me sign up with my account. For running model on real-time video, see, if you're using YOLO model, so if you're using CPU also, your latency would be like super fast, Abhishek. But if you're using some heavy model like faster RCNN, okay, then you need a GPU based system. But nobody uses actually faster RCNN nowadays because YOLO is getting more, I mean, more popularity when it is like super powerful. Edge devices are necessary for running computer vision based on application. Yes, edge devices also you can also run. Even Arduino supports actually different um, framework nowadays. There is a website called Edge Impulses. Okay, Edge Impulses. Okay, so this is the computer vision platform. So here you can train object detection model, image classification model. Okay, and you can deploy on the edge devices. You can directly import to the Arduino library, and there you can do it. Maybe I can take another webinar. I can show you. Okay, how to use that. But as of now, this is not our agenda. So we have already logged in, I think, in our RoboFlow. So where is the RoboFlow universe? So here is the helmet detection data. If I refresh, yeah. So now you can see download project is coming. Okay, now from here you can download the data. So first of all, you have to see the GPU. So let me see my GPU. So here I'm using free collab. That's a Testa T4 GPU I got. If you click on the runtime, change runtime type. Here is the GPU I selected. Okay. Okay. Now, to use the YOLO V11, you have to install this particular package called Alterlytics. Okay. So inside Alterlytics, this YOLO model is there. So let's set up the package. Then let's import the Alterlytics. Now you can see the version of the Python torch. Okay, everything. Now we'll import YOLO from the Alterlytics. Then we'll download the data from the RoboFlow universe. How to download? Click on the, so here is the data. Let me refresh. Click on the download project. Okay, forking copies, source of the copies in an account, choose the whatever use photo settings. Let me do one thing. I can reopen it again. Okay, first of all, fork it. Let's then try to do it. So if you want to annotate your own custom data, so for this there is a platform you can use, RoboFlow annotator. Okay, even there are some tool like label me, label img. With the help of that also you can annotate your data. But in the universe, all the data set are already annotated. You don't need to do the annotation. Okay, this is the main advantage. So basically what you have to do, so see the data actually, this is the code. So here you have to give the data name. And if I execute, see, it will automatically download the data from the RoboFlow universe. See. Okay. Now if I refresh, see, this is the data it has downloaded. So inside that you have the training images, validation images, okay, all kinds of images you have here. You can open it up and you can see the image. See, this is the helmet image. Okay, fine. So now let's see the location of the data. So it is available in the content helmet detector. Okay, this is the data folder. Now we can start the training. See there, that's how your like YOLO 11 is. So we don't need to do actually so many configuration. So after setting it, directly you can start the training. So here we are defining, I want to do the detection task and to train the model. This is the data location and this is the model I want to use. So YOLO 11 is having different model. Okay, it is having nano model. So let me show you. If I go to the Ultralytics YOLO 11 GitHub, so it is available in the Ultralytics. If we go to the model zoo, see it is having nano model, small model, medium model, large model, XLR model. I'm using the nano model, I think. Let me see. Yeah, nano model I'm using. Okay, and number of epoch I want to train 50 epoch, and this is the image size. Now let's start the training. And I'm using free collab, guys. See, okay, still I'll be able to train the model in a very easiest way. Yeah, hi Manoj, Manje Marma. So see, training has started. See, epoch has started. So 50 epoch it will train. Let's wait. So if you're using premium collab, that's I at that time actually the training time would be very, let's say, I mean fast. But I'm using free collab, that's why it's slow a little bit. See, I already trained. Let me show you the result. So I don't need to wait because it will take I think 10 minutes. Okay, to train the model. See, after that you can see the metrics, like this is the confusion metrics. This is the each and every classes present in the detection, like you have cycling helmet, half face helmet, hat helmet. Okay, this is the let's say distribution of each and every class. That means here you have this quarter face helmet having more images. Okay, you can see it is having more distribution. Then after that, this is the like training losses and accuracy. So that means my epochs is increasing, loss is also decreasing, epochs is increasing, MAP score is also increasing. MAP means mean average precision. This is the accuracy of the object detection model. If this is increasing and if this is decreasing, that means your model is learning well. There are some few like batch images example you can see. Okay, after that you can run this particular cell. It will load the test data and it will do the detection on top of it on the model you have trained. And this is the final result, guys. Now see, it is able to detect the helmet. So this is the half face helmet and this is the score. 99% confident your model is, this is the half face helmet. Now this is the cycling helmet, it is detecting. This is the half face helmet. Okay, that's how it is having different actually helmet. You can see nutshell helmet. All right, so entire notebook I'll try to share with you. So let me share it now. So I will share. You just execute, okay, from your side once. This is the collab notebook, guys, I have shared with you. Still you can see training is happening because I'm using free collab here. Fine. So everything, if you want to understand from scratch how to prepare the data and everything, so you can join this particular course, okay, computer vision with real-time development. So here we'll try to discuss in detail. Yeah. So anyone having any query about the computer vision, let me know. Any query, guys? I trained model by watching your video. Now I want to deploy YOLO on the AWS cloud. How to do that? So to train, deploy the model, I will make a video, okay, how to do it, do the deployment. Even maybe in my YouTube channel, I already created a, uh, let me show you. I have some project actually I created. Maybe there I showed you the deployment, how to perform it. So here I think computer vision project, end-to-end object detection project. So you can see this playlist, okay, end-to-end object detection project. So here I showed you the deployment, okay, how to perform CI/CD deployment with the help of Jenkins. Yeah, what is the latest trend? Latest trend means currently we have different uh, very powerful model like YOLO is there, okay. YOLO is actually latest trend nowadays in the computer vision, okay. So this thing will try to more focus on. So not only you can perform the object detection, even you can perform the uh, see you can perform segmentation also with YOLO. You can perform classification also with YOLO. You can perform post detection. You can perform oriented bounding box also. Okay, everything can be possible. Hmm. Can you share the notebook under the resources section? Yes, after the webinar in the dashboard, this notebook would be shared. Okay, Amarnath. And to get actually latest update, you can refer this website, Papers with Codes. Okay, so here all kinds of computer vision, Gen AI. Okay, all kinds of research actually you can see. So you can simply search for computer vision research to see actually different computer vision like um, they propose this particular model sequence, but okay, what computer vision teach NLP, that means this is the hybrid architecture. So they're using computer vision architecture as well as the NLP architecture, and they propose this model. Then cornea, then CV nets. Okay, see these are the actually different models are coming. Got it? Yeah, that's how you can keep yourself updated with the latest technology. You can see the paper as well as the code implementation as well. Okay, so that's how I always keep myself updated with the latest trends. How production grade annotation normally handles for the huge data sets. Nowadays there are some AI tool that will help you to do the auto annotation, but at the end you need some manual observation there. Okay, probably if you have a huge amount of data set, but at the end you have to pay for some money. Okay, and most of the like image data set we do the annotation manually. We use some tool like label me and label img roboflow annotator. Okay, with the help of that we can annotate the data. Hmm. So in my YouTube channel also I created some tutorial. Let me show you data annotation with different tools. Let's say there is a playlist I created called computer vision with RoboFlow. So here I think I showed you data annotator. See how to perform data annotation using RoboFlow. You can check it out this playlist. Okay, this video. Okay, so there I showed you how to annotate the data. Then if you want to perform auto annotator, so for auto annotator also I created some tutorial. So mm, automatic data labeling using Microsoft Florence to Vision multi-model. Okay, so this video you can see again this one you can see automatic segmentation data annotation. Okay, then how to perform data annotation for the image segmentation. See, so many computer vision related projects content I already have in this playlist. You can check it out. Okay, and if you want to understand everything from scratch, you can check this course. So let me give you the course link in the chat so you can enroll. If you want to buy the Euron Plus subscription, this is the link. Okay, fine, guys. So I think you got it about the visual intelligence. What is this exactly? That means this is the copy of the visual cortex at the end. Okay, and inside that we perform different tasks. Okay. So yes, guys, this is all about from my side. I hope you like the webinar, and if you want this kinds of webinar, you can let me know, guys. And see, there is a webinar section in our platform. So let me show you. If we go to the home section, so here is the webinar. So all the upcoming webinar you can see here. Okay, so you can attend anytime. You can register yourself. And there is another features we have integrated with the Euron called focus mode. Okay, if you need any focus, So you can also open the focus mode. Let's say I will give some background music. You can set the timer. Okay, that's how you can set your focus. Yeah, thank you, Amarnath. Thank you, guys. Yeah, webinar, it is free for all. Okay, even you will also generate the certificate after that. So after this webinar, you can generate the certificate, guys, all of you. So here you can check. Let me show you. Let's say this is the webinar. So I think you did the registration. So you have to do the registration. Okay. So after doing the registration, if this webinar is complete, you can generate the certificate from there. Okay. And you can post over the social media. Yeah. Thank you, guys. So, okay, guys, thanks for joining, all of you. And always remember, consistency is the key. With that, guys, thank you so much. Bye, everyone. Good night. Bye. Thank you.